Alright, so this is video 4. It says solving absolute value inequalities. So I'm going to do number 13. So number 13 says we have negative 9 plus p is in the absolute value, and then plus 5 is less than 24. They're asking for the solution set. They want the interval notation, and then they're asking a question about the test point. So let's first solve the equation. Remember, the first thing you always do, guys, is you isolate your absolute value. I like to make my absolute values dark so that way you can tell that it's an absolute value and not a 1. So in order to get this guy by himself, I'm going to subtract 5 from both sides. Bring down the absolute value. Negative 9 plus p still chilling on the inside. We have your less than sign right here. 24 minus 5. That gives me 19. And so now that I have the absolute value by itself, I'm going to split this into my two cases. Case number 1 is where you drop the absolute value bars and rewrite. And then case number 2 is where you stick a negative out in front, change your absolute value bars into parentheses. Okay, so the rule of thumb is, it's a rule. If you divide or multiply by a negative, right, a negative number, you must flip the sign. So what does that mean? If I have a sign that says less than, that's going to go to greater than, or vice versa, right? If I have a sign that's less than or equal, then it's going to switch to greater than or equal. So the equal stays. If it's there, if there's no equal, there's no equal on the other side too. So first case, let me go ahead and solve that guy. I'm going to subtract p, right? And it's, even though I subtracted here, I'm not flipping the sign because I just subtracted. I'm not dividing or multiplying by a negative. So actually, I don't want to subtract p. Sorry. I want to add 9. I want to get p by itself. My bad. Just messed up right there. So p is less than 19 plus 9. Is that 18, 28? So p is less than 28. And then here, you can distribute the negative if you want to because you don't have an absolute value anymore. You can never distribute a negative into an absolute value up here, but here you can. But the easiest thing to do is go ahead and flip and switch. So I'm just going to divide by negative. Now I'm going to flip the sign. So this less than now becomes greater than. And then 19 divided by negative 1 is negative 19. To get p by itself, I'm going to add 9. Speed up just a little bit. So I get p is greater than negative 19 plus 9 gives me negative 10. Okay, so those are my answers. If I'm going to write my solution set, right, so let me go ahead and draw a little number line just so I can see this a little bit better. I need to scoot this up a little bit. So I have 28 here, and I have negative 10 here. This says, p is less than 28. So open circle, because there's no equal sign. And less than means you're going to go this way. And then here it says p is greater than negative 10. Open circle, so you're going to go this way because it's greater than. So I'm going to shade everything in between. Yep, just like that. So if I was doing my solution set in set builder notation, right, I always tell my kids this looks like a dumbbell, right? So since it looks like a dumbbell, I can write it with my inequalities as 1. So I have an x in the middle, right? Don't forget your curly braces. X in the middle, negative 10 on the left, 28 on the right. Arrows always point to the left, and that's it in set notation. In interval notation, I have my farthest to the left, I have negative 10. Farthest to the right is 28. Since it is not included, right, these are open circles, you have parentheses. It looks like a coordinate, but it's not. It's an interval notation of the domain. So those are your answers for set and interval. The last thing they're going to ask us is a test point. So can P be 30? right? Well, here's the deal. If I look at my number line, where does 30 lie on my number line? Is it less than negative 10? Is it in between my answer choices, or is it greater? So 30 is actually on this side of 28, right? So if you see, my answer choice can only be where my dumbbell is. So 30 is outside. So no, P is not 30. 30 cannot be P. Now, if I would ask 28, that's kind of tricky, right? Because 28 looks like it could be my answer, but it's also an open circle. So that would also not be P. Same thing with negative 10. However, if this was closed and I said, is 28 an answer, then you could say yes, because it's closed. You always have to remember whether these endpoints are included or not, whether it's open or closed. Okay, so that's number 13. Let's go ahead and look at number 15. I have negative 3 plus absolute value of n minus 2 is greater than 5. Alright, so first thing I'm going to do is isolate my absolute value, make these guys darker. To get rid of this absolute value, I first have to get rid of this negative 3. So I'm going to add 3 to both sides. So I get the absolute value of n minus 2 is greater than 8. Alright, now that I have the absolute value by itself, I'm going to switch into two cases. I have n minus 2 is greater than 8. And then I have negative n minus 2 is greater than 8. Just like that. So now I'm going to add 2 to both sides for this guy to solve for the first case. So n is greater than 10. That's my first answer. And then here I'm going to divide by negative, flip and switch. So you get n minus 2 is less than negative 8. Flip the sign. Notice I flipped the sign. And then I'm just going to add 2 to both sides. So I get n is less than negative 6. Okay? So I'm going to draw my number line. So I have 10 is on this side and negative 6 would be somewhere on this side, right? Alright, n is greater than 10. So greater than 10, I'm going to have an open circle because there's no line underneath, and it's going to be to the right. So this part's shaded. And then n is less than negative 6. So also open circle, the numbers less than go to the left. There we go. So if I want to write my solution set in set builder notation, write curly brace, x, draw your line. This is not a dumbbell, guys. Be very careful, not a dumbbell. So let's do this guy first. N is less than negative 6. And then we have n is greater than 10. What goes in the middle right between? There's a break. So it's not a U. U is for interval notation. If it's set notation and there's a break, you write the word or. And so that's set. And then I think that's all they wanted us to do, right, for 15? Good. And if I was writing this in interval, I'll go ahead and do this right now so y'all can practice, because this is something huge in pre-cal. If you were writing this in interval notation, it would be negative infinity to negative 6. Remember, infinities always have parentheses. Negative 6 would have a parentheses because it's open. And then the break, instead of or for interval notation, you put a U for union. And then 10 to infinity going the other way. And so in this case, you would have open. So it's parentheses, infinity, open. Guys, domain, always like you read a book, left to right. If you start going the other way, it's going to be a funky notation. So make sure you guys left to right. Those are the difference between set and interval notation. Alright, last one we're going to do on this video is number 16. The fraction. That was a little funky. So number 16 on your review says you have the absolute value of 2 plus 3x on the top. Divide it by 2. It's greater than or equal to 5. And they want me to, they ask about a test point, and then here they're just asking us to graph the equation on a number line. Alright, so to isolate the absolute value, guys, I need to get rid of this 2. They are dividing by 2. So opposite of division is multiplication, so I'm going to multiply by 2 over 1. What I do to one side, you have to do to the other, right? So this guy cancels. So I get the absolute value of 2 plus 3x on the left is greater than or equal to. When you're multiplying fractions, don't freak out. Multiplying, you multiply top with top, so 5 times 2 is 10, bottom with bottom. 1 times 1 is 1. Alright, so now I'm going to split into my 2 cases. So case number 1, you have 2 plus 3x is greater than or equal to 10. I drop the absolute value. Case number 2, stick a negative in front, replace the absolute value with 2 plus 3x. Remember, the reason why we do 2 cases, guys, is because absolute value is a v, right? The graph is a v. So your distance from that point, you have a negative side and a positive side. Alright, so solving on the left, case number 1, I'm just going to subtract 2 really quickly. 3x is greater than or equal to 8. And then I divide by 3. It's okay to have a fraction, guys. This is a nice, pretty fraction. This is not like 1 million over like 207. 8/3 is okay. I know a lot of you guys think you started doing something wrong. You didn't. Remember, you can always plug this back into your previous function or the main function on the top to see if you did it right. You should get the answer to be 5. So 8/3, x is greater than 8/3. Here I'm going to divide by negative. So you get 2 plus 3x, flip the sign, is less than or equal to, right? Make sure you flip it. And then 10 divided by negative 1 is negative 10. I'm now going to subtract 2. So I get 3x is less than or equal to negative 10 minus 2 is negative 12. Divide by 3. So x is less than or equal to negative 4. Alright, let me graph this down a number line because I know we have a scary fraction and that's a little weird. So I know negative 4 is going to be smaller, so he's going on the left because it's a negative number. 8/3, and I want you guys to be smart about this. Don't plug 8/3 in your calculator right now and think and try to find what number it's between. Let's be logical about it. Let's be smart. Alright, 8 divided by 3. How do I do that? You guys remember in like 3rd grade, right? Count by 3s. So 3, 6, 9, 12, right? So 3, 6, 9, 12. Where does 8 fall between these numbers? 8 falls between 9 and 12, right? That's where 8 is. So this is the first number, the second number, the third number, and the fourth number. So 8 divided by 3 is going to be 3 point something because it lies between the third and fourth number when you divide it. So this is, ooh, sorry, it's black. So this is going to be between 3 and 4. So if I draw a 3 and I draw a 4 right here, 8/3 will be somewhere right in the middle. Like I said, don't freak out. It's okay. Fractions, we can overcome fractions. Alright, so here it says x is less than or equal to negative 4. So close circle, and it's less than that. So that's going to be to the left. And this one is going to be equal to also, so close circle, and then to the right. Okay, I just looked at my work and found out that I made a huge mistake. Sorry. Okay, 8 is not between 9 and 12. 8 is between 6 and 9. Sorry, guys. It's late on a Saturday. So 8 is between 6 and 9. You're probably looking at this video like, what is she talking about? So my answer should be between 2 and 3, not 3 and 4. There we go. There's 8/3. So this should all be shaded this way. Sorry about that. Miss Morness, what are you doing? Alright, 8 divided by 3 is between 6 and 9. There we go.
So it's 2 point something. So I'll scratch this out. Okay, so it says test point, can x be 2? So can x be 2? What do y'all think? Well, 2 is right here, and is that part of your shaded region? No, because we said 8/3 was between 2 and 3, so it's greater than 2 and 3. So this is not a solution.